For section 8.5, the objective is to find the constant of integration c when given a point where the curve of the integrated function passes through. Then, in the previous tutorials, we were able to find the integration of any function, and by the end of this answer, we add the constant c. In this section, we are going to try to find the constant c in specific condition, or when we have a point that is going to pass through the integrated function. Let's go now to page 140, example 6. It says, the curve C with equation y equal f of x passes through the point 4, 5. Then we have a point that is going to pass through the y equation. Given that f prime of x, the derivative of y, equal x squared minus 2 over square root of x, find the equation of C. Now, we are asked to find the equation for the curve C that is passing through the point 4, 5. The equation of C is y equal f of x, and we have the derivative that is f prime of x. Then, in order to find f of x, we need to integrate f prime of x with respect to x. Therefore, we say f of x equal the integration of x squared minus 2 all divided by the square root of x by dx, or with respect to x. Now, the expression inside the bracket is somehow not a linear combination. So using section 8.4, we are going to transform this expression to a linear combination. So we start now with x squared minus 2 all divided by the square root of x. We have a common denominator, so we can split these two terms. So we get x squared over the square root of x minus 2 divided by the square root of x, which is the same expression because we have common denominator. Now we say x squared divided by, we get rid of the square root and write it in the form of power. So it's x to the power half. Same thing, minus 2 divided by x to the power half. Now, if we take x squared and it's the base, so we subtract the power of the denominator from the numerator, it becomes 2 minus half. Minus 2x to the power minus half. We took the reciprocal of 1 over x power half. So the result is x to the power 3 over 2 minus 2x to the power minus half. Now this is a linear form. So we can write, find the integration of x to the power 3 over 2 minus 2 multiplied by x to the power minus half with respect to dx. Now we take each term inside the bracket separately and we integrate it with respect to x. The first term we have x to the power 3 over 2. Its integration with respect to x is x to the power n minus 1, that is 3 plus 2 plus 1, not n minus 1, n plus 1, all divided by n plus 1, that is 3 over 2 plus 1, or 5 over 2, minus the second term 2 multiplied by x to the power n plus 1, that is minus half plus 1, all divided by n plus 1, that is 1 over 2, plus c, the constant that we add usually after integration. Let's now do some calculation. So to get rid of the denominator of the first term, we take its reciprocal, so it's 2 over 5x to the power 5 over 2 minus 2 multiplied by the reciprocal of the denominator of the second term, 2 over 1 multiplied by x to the power half plus the constant. Now this is equal to 2 over 5 multiplied by x to the power 5 over 2 minus 2 multiplied by 2 is minus 4 multiplied by x to the power half plus the constant c. This is then f of x or y. After we integrated f prime of x, we found f of x. As you observe, we used the methods or the strategies we learned in section 8.4. Now, we have the function f of x and it includes the constant c, as you can observe. we are asked to find the value of c. So the function becomes clear. Now we have the point x, y, or 4, 5 that is passing through the equation of f of x, which is y, given. Then we can rewrite this equation in the form of y, so it becomes y equal to over 5 x to the power 5 over 2 minus 4 x to the power half plus the constant c. Now let's substitute the value of the point or x and y, which is x equal 4 and y equal 5. Therefore, instead of y, we write 5 equal to 2 over 5 multiplied by x to the power, or instead of x, we write 4 to the power 5 over 2 minus 4 multiplied by 4 to the power half plus the constant c. Now let's do straightforward calculation. 5 equal 2 over 5 and 4 to the power 5 over 2. We can do it separately using the indices rules. 4 to the power 5 over 2 is equal to 4 is the same as 2 to the power 2 into the power 5 over 2. So we distribute now, or we multiply the power by each other. Then 2 multiplied by 5 over 2 is 5. Then it's 2 to the power 5 that is equal to 32. Then we substitute 32 minus 4 multiplied by 4 to the power half. 4 to the power half, it's the same as 2 squared to the power half, which is equal to 2 plus the constant. Now we continue with mathematical calculation. So 5 is equal to 2 over 5 multiplied by 32 is 64 over 5 minus 8 plus the constant c. Then 5 equal, we take common denominator 5, so it's 64 minus 40 plus c, the constant. Now we can say 5 equal to 24 divided by 5 plus the constant c. If we subtract 24 over 5 from both sides, then c is equal to 5 minus 24 over 5 equal to 25 minus 24 over 5, that is equal to 1 over 5. Then the constant c is 1 over 5. We did mathematical calculation and substituted the value of the point that we have in the equation f of x or y, so we were able to find the value of the constant c. Now we can write the equation again with the given value of c. The equation of the curve c is going to be y equal to 2 over 5 x to the power 5 over 2 minus 4 x to the power half plus 1 over 5, the value of c. As you can observe, given that the point that we have that is passing through the curve, we will able to find the value of the constant c. We did first some work in order to reform the expression into a linear combination expression, so it is easier to integrate. Then we substituted the value of c.